Assalamu alaikum. Let's begin with the first question of this paper. In this paper, they are representing a stack of slides, glass microscope slides, and what they're asking a student take measurements from a glass microscope slides in order to estimate the number of slides in stack. The side of the stack have been covered with tape so that the student cannot count the numbers of slides in the stack. Shows side view of the taped stack of slides given to the student. The figure has been drawn at the full scale. Okay, so these are the two figures that they are talking about. What they're asking in part A, using figure 1.2, there we have measure the length L, this length, the width W, this one, and the height H, that is this one. Okay, and you have to record it there. So let's measure them. Okay, so what will be the L? And you have to put your scale here. The zero of the scale will be on one side like this here, and other side is at this one. This is from this point till this point, it's 7, right? So this is sorry, it's 7.5, right? This is 7.5 centimeter. Units already there. Okay, so let's make W. So for W, you have to put the zero of the scale on the one side, and other is at this point, it is 2.5. Okay, and let's measure the height. For height, you have to place the scale perpendicular, exactly, and zero of the scale on the one side of H, and it's 1.123, it's 1.3 centimeter. Okay, so we are done with the measurement. In the next part, what they're asking, the student uses a balance to measure the mass of the covered stack of slides, and there they're showing the balance. Write down the mass M of the covered slide to the nearest 0.1 gram. Okay, so value is this 57.87 G. We have to write down it nearest 0.1 gram. Okay, so it's 57.8. We have to include only one decimal, right? Units are already written there. In the next part, second of it, they're giving us this equation and they're asking us to find the value and the unit of it. So let's do it. You just have to put the values. M was 57.8 divided by length, width, and height. Length was, it is 7.5, then it is 2.5, then it is 1.3. When you multiply all of them, what you will get, okay, this is 2.37. So it is 2.37, and for units, as we know, for mass it will be grams. This thing is centimeter, this is also centimeter, this is also centimeter. So 3 centimeters are divided, so centimeter into centimeter into centimeter, that will give you centimeter cube, and so it will be grams per centimeter cube. Okay, so let's move to the next part. In part C, use your answer to B1 and information from the card in figure 1.4 to estimate the number of microscopic slides N1 in the covered stack. Okay, B1, from B1 and from figure 1.4. So from B1, what we have, we know the mass in B1, that was the total mass, right? And what he is telling us here, mass of a single slide, we have to find the number of slides. Okay, so for this purpose, what we can do, N1 can be total mass divided by mass of one slide. Mass of single slide. This can give us the number of slides, right? So total mass was 57.9. That is the total mass, right, that we have. And this is the mass of a single slide, that is 4.2. When divided both of them, it will be 13.785. Okay, as we have to tell the number of slides, so number will be, it should be the whole number, right? It can be 13, it can be 14. So both answers are acceptable, but I'm writing 14 here because the answer is more close to the 14. Okay, so you can also write 13 if you want to. Both will be correct. Okay. In the next part, what they're asking, use your answer to A and information from the figure 1.4 to obtain another estimate of the number of miles. Okay, so we have to make another estimate. What information we have? We have thickness of a single slide. Okay, this is the thickness for the single slide, and we have above the thickness of the total slide, right? So you can use, what we can do here, N2 can be total thickness divided by thickness of single slide. Total thickness was 1.3. Single slide thickness is given here, that is 0.11. That will give us 11.818. So you can round it off to 12 or 11. I'm rounding it off to 12 because that number is more close to the 12. Okay. In the next part, they're asking, two quantities can be considered to be equal within the limit of experimental accuracy if their values are within the 10% of each other. State whether your values n1 and n2 can be considered as equal or not. Okay, and you have to support your statement with the calculation. So it's the 2-mark question. 1 mark is for the calculation, 1 mark is for the related statement. So what values we have? We have for n1 is basically 14, right? So its range will be, if I'm considering 10% of 14, that will be 0. 10% of 14 will be 1.4. Okay, so this value range will be from, minimum value can be 12.6 and maximum value can be 15.4. And when I talk about n2 is 12, so 10% of 12 is what? It's 1.2. So this value's range is, how I'm calculating the range, it's mean 12 plus 1.2 and 12 minus 1.2. Okay, this is the lower and the upper bound of this value. So this can be 10.8 till 13.2. Okay, so if you see these values here, this is 12.6, this is 13.2. So both the ranges are overlapping with each other, right? So they can be considered as equal when they are overlapping, right? So they can be considered equal. Okay, let's move to the next part. Suggest one reason why the estimated value of n are different. Okay, why they are different? We have estimated the value of n from the thickness of the slides and the masses of the slides. So the thickness of the each slide cannot be the same, maybe not, it will not be same, or mass can be the different, right? So we can say that slide can have different thicknesses, or you can say, or mass. Okay, so we are done with the question 1. In question 2, this is from the electricity part. A student measures the resistance of a light emitting diode when the current in it changes. The student sets up the circuit as shown in the diagram. Okay, there we have resistance 220 ohms, it's between P and Q. There is a LED that is between Q and R, and there is battery, power supply, and there is a switch. Okay, and there they are explaining the whole setup. What they're asking, draw the circuit symbol for a voltmeter connected to measure the potential difference across the 220 ohm resistor. Okay, so we have to draw a voltmeter. Voltmeter can be at this point. Okay, voltmeter is always installed in parallel with us points. You can install it here as well. Okay, it is also correct. So any one of them will be acceptable. So in the second part, the voltmeter reading is shown. Write down the reading in the top row of the table 2.1 under the heading VQ. Okay, let's see what the reading is. This is 2. This is 2.1, 2.2, 2.3, and this is 2.4. Each division is showing, see, each division is showing 0.1. Okay, so it's 2.4. So the value will be 2.4. Okay. In the next part, they're asking us, they have explained the circuit, they have given the equation for the current. Record your answer in the top row of 2.1. Okay, we have to record the answer for the current in the table. So there we have the table. The answer can be, the voltage of PQ is 2.4 here, and resistance R is here, that is 220. So this will give us 2.51. Sorry, it's not 2.5, it's 0.011. 0.011. Okay, then another equation for resistance of LED you have to record in the table. So let's put the value. Voltage of QR is given here, that is 2.1, and the current value we have calculated, this is 0.011. that will give us 190.9 ohms. So we have to record it here, that will be 190.9. okay, or you can write as 191. Okay, 191 if you round off. In D part, what they're telling us, they have removed the 220 ohm resistor from the circuit and replace it with 330 ohms resistor. Reconnect the voltmeter across the resistor PQ. Repeat the part AC for the 330 ohms. Use the information in table 2.1 to calculate the values of PQ across the 330 ohms. Show your working and record your answers in table 2.1. Okay, so let's move to the table. You have to fill these things. Okay, there is only one quantity that you have to do. Okay, so you have to write down the voltage. We know that voltage is this PQ will be current into resistance of PQ. Current is basically, there it is, it's 0.0076. Resistance is 330. So let's calculate this thing. It will give us 2.508 watts. So it will be 2.508 watts. Okay, so this is the voltage we have. So we are done with the table. All of the missing things are completed. In the E part, what they're asking us, as the resistor between P and Q changes, the current in the circuit changes. Use your result in table 2.1 to write down the result, that stating how the change in the current affects the potential difference across the LED and resistor R of the LED. Okay, so when you are changing the resistor, basically you are replacing the 220 resistor with a 330, right? In the circuit, let's look at the circuit. This was a circuit. You have replaced this resistance with 330 ohm resistor. Okay, so what will happen? The total resistance of the circuit will increase. That will decrease the current, right? Because this resistance will be more. There is only one path for the current, so this current have to move from this thing, and now there is more resistance, so current will decrease. So when current will decrease, this LED, its voltage is basically I into R, so its voltage will also, sorry, we have to tell its total current that is passing, and we have to tell the resistance, so its resistance will increase. Okay, so in this part you can say, as current is decreases, so voltage across LED also decreases. Okay, because we know that V is equals to IR. Okay, and we can say that resistance of LED also increases. Okay, so you have to comment on the current and resistance only of LED. The next part, they're asking us to draw the symbol for the variable resistor. Variable resistor, you have to make the rectangle and a line through it like this. Okay, in the next part, they are explain one advantage of using a variable resistor for this purpose rather than the procedure carried out in A. Okay, there are many advantages. First is, when you use the variable resistor, it is easier to change the resistance value. Or you can say, or you can write, you have to write only one answer, right? Because it's a 1 mark question. No need to connecting and disconnecting the circuit. Okay, if you use the variable resistor, so there are many benefits of it. It's very easy to use, and there is no need to connect or disconnect anything from it. So we are done with the second question. Third question is from the light portion. They have given us an experimental setup. A student investigate the image formed by the converging lens. The apparatus is set up as shown in the diagram. Okay, what we have in the diagram, there is the object that is illuminated. There is converging lens placed on a stand. Okay, and this is the screen, and the distance between the converging lens and the screen is represented as D. There they have explained all of it. And what they're asking, measure from the figure 3.1 the nearest value in 0.1 centimeter the image distance d from the center of the lens to the screen. Okay, so you just have to measure with the help of scale. So here is a scale. Place the zero of the scale on the one side, and it's it's 12 and one more point, so it's 12.1. It's 12.1 centimeter, right? Okay. In the next part, the figure is drawn to a scale of 1/5 of the full scale. Okay, so the figure that is drawn there is 5 times less than the actual thing. Calculate the actual image distance v from the lens and record your value in there. Okay, so this was the given. You have to write down the actual image of that thing. So to find the actual, the scale is 1/5, so you have to multiply 20 with 5. So it's not 20. We have, this is the distance, right? This is the distance that we have. So you have 12.1 into 5. That will be equals to 60.5. So 60.5 will be the image distance. Okay. Okay, so let's move to the B part. The diagram in figure 3.2 shows the illuminated object and its image drawn full size when u is 20 centimeters. State two ways in which the image differ from the object. Okay, so there is object and this is the image. You have to tell the differences that they have. One difference is the object and image, they are inverted, right? Image is inverted. What the inverted is, it's mean it's upside down. Okay. And second is object is small, image is bigger in size. So that thing is called magnified. Okay. In the second part, the magnification m of the image can be calculated by this relation that they have given. You have to calculate the magnification m of the image. Okay, so you have to calculate the magnification. We have to take the values of v and u from the v is 60.5 and u is 20. So you just have to put the values there. It's 60.5 divided by 20. That will give us 3.025. Okay, so you have to write down the answer. This, you can write 3.025 or 3.0 is also good to go. Okay. Okay, so in the next part, in part C, the student repeats the procedure in A first for value of U25, U35, U45, U55 and U60. And the student results are shown in the table. Plot a graph with y-axis. On y-axis you have to plot V, on x-axis you have to plot U. Okay, and you have to draw the best fit line. Okay, and there you have the grid. And okay, so on the y-axis you have to do, on the y-axis there should be V, so you have to label it V centimeter, and x-axis will be u slash centimeter. Okay, this is the first thing that you have to do. Okay, we don't have to do the scaling as it is already done, so we just have to locate the coordinates here. Okay, so coordinates are, let me check the table. This is the table that we are going to follow. Okay, so this table, first value is from the table, it's 20 and 60.5. So there is 20. Okay, this is the 20 and 60.5. Each box is showing 1. So this will be 60.5, so it will be somewhere at this point. Okay, so it will be 20 and 60 point. It will be somewhere at this point. Okay, this coordinate is basically 20 and 60.5 that we have drawn. Okay. Okay, the next one is 25 and 37.2. So where is 25? This is 20, this is 30, this will be the 25. Okay, this is 25, and on y-axis 37.2. 37, this is 35, 36, 37, 37.2. It will be somewhere at this point. Okay, so you have to somewhere at this point. Okay, then the next is 35 and 26.5. So 35 is at this point, and y-axis is 26.5. 26.5 will be somewhere at this point, so this will be the point. Okay, next is 45 and 22.7. 45 is there, and 22.7 will be somewhere at this point. Okay, so this will be the point here. Okay, then the next is 55 and 20.9. So 55 is there, and 20.9. 20.9 will be almost, this is, so this will be the point almost. Then 60 and 20.2. This is 60 and 20.2. 20.2 will be at this point. It's at this point. Okay, so we have all the coordinates. What we have to do, we just have to now make the best fit line. So as it is very clear from the coordinates, it will be a curved line moving like this. Okay, so this will be your graph. It's your choice. You can remove these lines, or you can leave them as it is. Okay, so this is the graph you have. In the D part, use your graph to find the value of V when U is 30. Show clearly on the graph how you have obtained this value. Okay, you have to tell the value of V when U is 30. When U is 30, this is U30. Okay, then you have it's 31. Okay, so then V will be 31, or you can say 30. Okay, it's 30, 31. Okay, then you have to find value of F, and the relation is given. You just have to put the values. So if we put the values here, U is 30, V is also 30. It's 30 plus 30. So it will give us 15. So this is 1.5. Okay. In the next part, they're asking, state one technique you use when doing the experiment to ensure that the image on the screen is as clearly focused as possible. Okay, this is a very common question, the light part. What you can do, first thing, we can move screen slowly to and fro. Okay, why we move the screen to and fro? To shift the screen on the focus of the lens, right? So when it is on the focus point, the image will be clear. Or you can write, there can be other answers as well. It can be carry out the experiment in dark room. Okay, this is the improvement that can be done in the light experiments. Or there can be another answer, you can use the brighter object. Okay, you just have to write down any one of the answers. Okay, don't overwrite. In the fourth question, this is the planning part. What the scenario is given, hot water is poured into a glass beaker and allowed to cool down. Plan an experiment to investigate how the rate at which the water cools depend on diameter of the water surface exposed to the air. So what you have to relate the cooling rate with what? With, you have to relate with the diameter of container, right? So you have to relate them. So you can say that the surface area, right? Basically this concepts, this question is basically depends on the phenomena of evaporation. And we generally know that when you increase the surface area, the evaporation will increase, and evaporation is basically the cooling process, right? So rate of cooling depends on the evaporation, that depends on the surface area. We have to design some experiment. What we have a supply of hot water, we have a set of glass beakers of different sizes, and we can measure the, we have a measuring cylinder. What we have to do, any other apparatus that is needed, a brief description of the method, and we have to include what you will measure and how you will make sure your measurements are accurate. Okay, then you have to include the key variable you will control, that is called the constant variables, a result table to record your measurements you have to draw. Okay, and you are not required to enter any value in that. How you will process your result to reach the final conclusion, right? You may include a label diagram if you wish to. Okay, so there are different ways to do this thing. What we can do is, so you can draw the diagram if you want to. In the diagram, what we can show there is, let's suppose, different containers. Okay, this is the container, there can be a container of different diameter. Okay, there can be a container of a different diameter, and you can fill them with the liquid, right? Okay, then how you will measure diameter, this is the diameter basically from this end till this end. You can say this, the diameter, name it D. This diameter is this much, this diameter is this much. Okay, then what we can do, we have to measure the rate of cooling. So it's mean you have to measure the temperature. Okay, so temperature, for temperature you need thermometer that you can place here, right? It can be the thermometer. What else you need? When you are noting down the cooling rate, you need the time as well. Okay. So how we can plan what we are going to need? We have to measure the diameter, we have to measure the temperature that is decreasing, and we have to measure the time. Okay. So let's start with the additional this point, any other operators that we need. So you can make the headings additional apparatus. First thing we need stopwatch, we need ruler, we need thermometer. These three things are required. Okay. Then they're asking constant, the key variable that we're keeping constant. Okay, it's your choice, you can break down the sequence, so you can go in the sequence. Okay, I will prefer to write down the key variables that I will keep the constant. Okay, so constant variables, what I will keep the constant. Achha, first thing we have to take constant volume of water. Okay, then what else? It can be, it should be the initial temperature. Okay, if you change the initial temperature of the water, the cooling rate will change. Basically the cooling depends on the difference between the room temperature and the temperature of the water, right? So if you are changing the initial temperature of the water, it's mean the difference is changing, so that will also change the cooling rate. Okay, so we will not be able to see clearly how the diameter of the beaker is changing the evaporation rate. The third thing that we will keep constant, time that we will give for the water to cool. Okay, time of cooling. These three variables we will keep constant. Okay, now what we are going to do in this part is basically the method that we adopt. Okay, so in method we take beaker and fill it with water of measured volume. Okay, then when you fill it with the measured volume, what we will do, note the initial temperature and let it cool for set period of time. Okay, then what we can do during cooling time, keep taking the values of temperature in equal interval of times. Okay, so now what we can do, we can repeat this thing to get the more accurate value. Repeat this experiment and take average. Okay, this line that I'm writing down, repeat this experiment and take average, this is for the additional mark. Okay, so when you write this thing, you will get the additional mark that is allocated for this thing. Okay, What we have to do, we have to now change, or we say we now take the beaker of different diameter and repeat the whole process. Okay, so after this thing, you are changing the diameter of the beaker and you are repeating this process. Okay, and take readings with 5 different diameters. Okay, that you can do. Okay, so this is the methodology part that we are done with. Now you have to draw the table. Okay, we are done with brief description of method. Okay, we have to include, okay, what we are measuring, we have included. How you will make sure your measurements are accurate. Okay, for accuracy, what we can do, okay, we are making the temperature, so one accuracy can be make sure thermometer is not touching the surface of beaker. Okay, this can be the precaution, or you can write down that make sure the beakers are insulated. Okay, so no heat is lost by the sides of the beaker. Okay, so we can correctly see the difference in the diameter, effect of the changing diameter, right? So these type of precautions can be written. Next thing that we have to do, we have to draw the table. So for the table, what you can do, you can, okay, make a neat table here like this. I'm not making much more rows because we don't have to fill in any data, we just have to write down the headings. What we have measured the diameter, its units will be centimeter, and what we have measured, the cooling time, right? So you can say cooling time, you can write down here in second. Or you can make or you can make the table with the diameter and the temperature as well. Both are correct. Okay, you have to choose any one of them. So this will compare how the changing the diameter will change the cooling time. If you make the table between the diameter and temperature, so this will compare the values that how the diameter change can change the final temperature in a fixed interval of time. Okay, so it depends how you're dealing with this. You have to make any one of them. Okay, and what we are left with, this point, how you will process your result to reach the conclusion. To process the result, what we can do, we can plot graph to compare the values. Okay, so this is how we conclude. Okay, so we are done with this paper. See you with the next video.